Hi folks. Today's target is to relate stoichiometry to things in our everyday lives. We're going to be doing that in a couple of different ways. Today I'm going to be going over a practice problem where we're going to talk about how making grilled cheese, just making a grilled cheese sandwich, is effectively doing a very basic level of stoichiometry, and to try and get you guys thinking about how stoichiometry is used in your lives, whether it's in cooking or just in other ways. So let's get into that. First things first, we need to talk about just what exactly is stoichiometry. First of all, it sounds like a really scary word, stoichiometry, like it's this unfamiliar word that nobody's ever heard of before. I like to affectionately call it stoic, because quite frankly, once you understand stoichiometry, it's one of the most useful things and frankly most logical things in chemistry. But you have to get there first. Okay, so what exactly is stoichiometry? Stoichiometry is a series of calculations using conversion factors. All right, so what is a conversion factor? We've actually used a bunch of different conversion factors. Some examples here, conversion factors. Some examples would be 12 inches in 1 foot. That is a conversion factor. It's just a comparison of two numbers, a ratio of two numbers that have different units. While the numerical value of these units is different, their value is the same. It's kind of like saying 100 pennies is equal to $1, right? Even though 1 is different than 100, the value of 100 pennies is the same as the value of $1. Or 1 mole equals 6.02 times 10 to the 23rd atoms, right? Avogadro's number is a ratio. 1 and 6.02 times 10 to the 23rd are very different, but because they have different units, their value is the same. Stoichiometry is just a process of using these conversion factors. We've already done a little bit of stoichiometry. We've done mole stoichiometry. This unit, we're going to take information from our mole stoichiometry unit and our balancing equations unit and combining them together to use stoichiometry with balancing equations. Wonderful. All right, so the big challenge for you guys today is to think of ways that this can relate to your everyday life. So how does it relate to your everyday life? Let's go over an example of that with grilled cheese. All right. So in today's practice problem, let's say you've got 5 family members, including yourself, and each family member wants 1 grilled cheese. You need to figure out how many slices of bread and how many slices of cheese you're going to need in order to make enough grilled cheese to feed your family. Some of you may have already figured out the answer to that very question I just posed. And if you did, great. Hey, that's awesome, you're already one step into it. But it's important to figure out how you got there. Today's stoichiometry problem is going to be relatively simple. And as the week continues, we're going to progress into relatively more challenging problems, as we do every week, right? And so let's create a process for how we solve these stoichiometry problems. Okay. So first things first, we need to just kind of figure out what our problem actually is. We need to set up the problem. We need to write out an equation. Okay, so how do we write out a balanced chemical equation for grilled cheese? Well, we do it the same way that we write out our chemical reactions. So our equation, we know that in order to make a grilled cheese sandwich, we are going to need 2 slices of bread, and we're also going to need 1 slice of cheese. And when we take our 2 slices of bread and our 1 slice of cheese, that will create 1 grilled cheese. Fabulous. Okay, that took a lot of time to write. See, chemists, we are efficient. Instead of writing out entire sentences, we like to abbreviate things. Instead of writing out hydrogen, we just write H. Instead of writing out oxygen, we just write O. So for our equation or our recipe, let's just abbreviate these words so that it doesn't take as much time to write it in the future. Okay, so for my abbreviated equation, let's say I've got 2 slices of bread. I'm just going to abbreviate bread to BR. So I've got 2 slices of bread reacting with 1 slice of cheese to produce 1 grilled cheese sandwich. Cool. We've got ourselves a balanced chemical equation. Step 1 done. All right, so what is step number 2? Step number 2 is identifying other things that we know in this problem. So what other things do we know in our problem? Let's just kind of review what the problem was. First things first, we know we need to make 5 grilled cheeses, right? Because we've got 5 family members, and so we're going to make 5 grilled cheeses. What we need to figure out is how many slices of bread and how many slices of cheese we're going to need. Okay. What else do we know? Well, let's identify our conversion factors. Remember from our past little segment, a conversion factor is just a ratio of 2 numbers. So let's use our equation to find some comparisons between these numbers. I know that in order to make 1 slice of grilled cheese, I'm going to need 2 slices of bread. So a conversion factor would be 2BR is equivalent to 1GC. That's a conversion factor. And I also know 1 slice of cheese is equivalent to 1 grilled cheese. I'll need 1 slice of cheese to make 1 grilled cheese. These are conversion factors. Okay. In stoichiometry, we would call these things mole ratios. Cool. All right. I'm going to quickly just kind of rearrange the board so I've got some more space. Okay, so I've just rearranged the board a little bit. I've still got my balanced recipe or my balanced chemical equation. I've still got my conversion factors or my mole ratios. And I've got the things that I know as well as the things that I don't know. Cool. All right, so what is step number 3? Step number 3 is to use what we know to find what we don't know. Cool. And one thing that's really nice about this process is you can kind of see the chronological order going here. We set up our balanced chemical equation. Using that balanced equation, we got our mole ratios. And now we're going to use our mole ratios from step number 2 and step number 3. Okay, so in all of these problems, there's going to be a number that you know. In this case, we know we're going to need 5 grilled cheese. Cool. Okay, so how can I convert my grilled cheeses into slices of bread? Well, I know that 1 grilled cheese is equivalent to 2 slices of bread. So what I can do is I can multiply my number of grilled cheeses by that conversion factor. 1 grilled cheese sandwich is equivalent to 2 slices of bread. There we go. Okay. So then I need to do my math. What I'm going to do is I'm going to take 5 times 2 and divide it by 1. So 5 times 2 divided by 1 is just 10. Okay, I also have to include my units. One of the really nice ways about how I'm setting this problem up is that because I've got my units in the problem, I can visually see what my units are going to be. See, I've got grilled cheese divided by grilled cheese, GC divided by GC. Well, anything divided by itself equals 1. And so my grilled cheeses, they just cancel out. So the only unit I have left is slices of bread. Nice. All right. So now that we know we're going to have 10 slices of bread, how do we figure out how many slices of cheese we're going to have? Well, let's do that. So once again, I'm going to use a number that I know. I'm going to start off with the exact same number that I used last time. I know that I need 5 grilled cheese. And the reason that I'm choosing that is because really that's a number that I know. You could use slices of bread as well, but I think it's going to be easier to use grilled cheese because we already have conversion factors for that already set up. Okay, so we've got 5 grilled cheese. And what we're going to do is, just like last time, we're going to use, can you guess? Cool. We're going to use our conversion factor to convert grilled cheeses into cheeses. So we know that 1 grilled cheese is equal to 1 slice of cheese. So our grilled cheeses are going to cancel out because grilled cheese divided by grilled cheese equals 1. 5 times 1 divided by 1 equals 5 slices of cheese. So I know that in order to create 5 grilled cheese, I'm going to need 10 slices of bread and 5 slices of cheese. Cool. So that's one way that we use stoichiometry in our everyday life. Now some of you may be saying, Mr. Hempstead, that was so much work for such an easy problem. And it was, you're right. That is a lot of writing to figure out how to make a grilled cheese sandwich or how to make 5 grilled cheese sandwiches. But what if I asked you how to create 120 liters of water with 24 liters of hydrogen gas and 2 moles of oxygen? That gets really complicated. And so identifying the steps that we use, identifying the process with something simple like grilled cheese allows us to do more complicated stoichiometry problems later on down the road. Cool. How many grilled cheese sandwiches could we make if we had 20 slices of bread and 5 slices of cheese? I'll post that up on the board real quick and then go ahead and try it. Cool. Here's the word problem that I just mentioned. Go ahead and see if you can solve this problem. All right, now that you've had an opportunity to go over it, let's break it down into our respective steps. We've already done step number 1. We've already created our balanced equation. Okay. Step number 2 is to identify what we know. So we know that we've got 20 BR, and we also know that we've got 5 slices of cheese. But this time the thing that we don't know is we don't know how many grilled cheeses we can actually make. So what we kind of have to do is do 2 problems. So let's take one of the numbers that we know and let's use those conversion factors that we've talked about. We know that 2 slices of bread will be used to create 1 grilled cheese. And we've got 20 slices of bread. Okay, so which number is going to go on top of my ratio and which number is going to go on the bottom? Yeah, 2BR goes on the bottom and 1 GC goes on the top because I need my BR to cancel out. 20 times 1 divided by 2 equals 10 grilled cheese. Cool. All right, I've also got 5 grilled cheese. Or sorry, I've got 5 regular slices of cheese. Sorry, 5 regular slices of cheese. And I know that 1 slice of cheese can be used to create 1 grilled cheese sandwich. So what I can do is I can once again multiply by my conversion factor. 1 slice of cheese is equivalent to 1 grilled cheese sandwich. So I put my cheese on the bottom so that the slices of cheese cancel out. 5 times 1 divided by 1 equals 5 grilled cheese. So we got 2 different answers. One of our answers is saying 10 grilled cheeses, and one of them is saying 5. So which is it? How many grilled cheese can we actually make? Well, the answer is we can make 5 grilled cheeses, and we'll have some bread left over. Specifically, we'll have 10 slices of bread left over. But the reason that we can't make 10 slices of grilled cheese is because we run out of regular cheese. Our cheese in this particular problem is what is called a limiting reactant. Because it limits our reactions. It limits this reaction to 5 grilled cheese sandwiches. And our bread is called our excess reactant. And it's called the excess reactant because there's going to be leftover bread. There's going to be extra bread once we've finished making our 5 grilled cheeses. Because we've got enough bread to make 10 grilled cheeses, but we don't have enough cheese to make 10 grilled cheeses. We only have enough cheese to make 5. So cheese limits the reaction because it stops the reaction when it runs out. And bread is the excess reactant because there is extra bread when we are done with our reaction. Cool. So let's quickly come back to today's target and relate stoichiometry to things in our daily lives. Cooking is a great place to go. Think about different, things that your families have cooked in the kitchen. Or think about any time that something changes into something else. Think about what was there originally and what it turned into. And think about what the chemical equation would look like. And you're well on your way to applying stoichiometry to your everyday life. Tomorrow we'll be starting a project. What you'll want to do is think about a recipe that has 3 to 4 ingredients in it that you could use for our project. You will be cooking this recipe, so simpler is a good move. All right, take care, folks. Bye.